Get ready for your weekly dose of news about latest discoveries and breakthroughs in the realm of science. Move over, T-Rex. There's a new dino in town. A team of paleontologists has discovered a new dinosaur species in Thailand. The fossil was found in Phú Noi, northern Thailand, in a geological area known as Phu Kradung Formation, which has been a rich source of fossils over the years. Researchers said that the fossil was an exceptionally articulated skeleton and was one of the most well-preserved dinosaurs ever discovered in Southeast Asia. This previously unknown species is now named Minimocursor phunoensis. And guess where the name comes from? Phú Noi, the place its fossil was discovered from. It was found that it is of the Neornithian clade, which were herbivorous dinosaurs. The researchers further suggest that it was a young dinosaur. It had 4 limbs but walked on 2 legs, had a long body and a long tail. It had a beak-like snout and a bony lump on its jaw, and a ridge along its pelvis. It ran quite fast to evade predators. The team estimates that it was only about 60 centimeters long, but they assumed that it would have been about 2 meters long at an adult stage. It was estimated that the dinosaur lived between 145 to 163 million years ago. New hope arises in the fight against neurodegenerative diseases like Alzheimer's as researchers from the University of Pennsylvania uncover a promising breakthrough. Alzheimer's is primarily characterized by the abnormal accumulation of proteins called tau proteins in the brain. These proteins form clumps called neurofibrillary tangles, which interfere with communication between brain cells and eventually lead to their death. As brain cells die, the brain's ability to function properly declines, resulting in memory loss, confusion, and difficulty with daily tasks. Apart from Alzheimer's disease, the clumping together of tau proteins into tangles is linked to more than 20 other conditions that involve dementia and movement problems. These conditions are collectively referred to as tauopathies. The exact reason behind clumping of tau proteins into tangles in these diseases are still unknown, posing a significant challenge for the development of effective therapies. In many living organisms, there are systems that ensure proper protein quality by removing faulty proteins and preventing the formation of tangles. But until now, scientists were uncertain about how this system works. They have now identified the gene responsible for regulating tau function. This finding provides a promising avenue for developing potential treatments to prevent and slow down the advancement of Alzheimer's disease and related disorders. This gene encodes a protein called tripartite motif protein 11 or TRIM11. By studying post-mortem brain tissues from individuals with Alzheimer's disease and healthy controls, researchers discovered that individuals with Alzheimer's had significantly reduced level of TRIM11 protein in their brain compared to healthy individuals. TRIM11 has 3 important roles in maintaining the quality of tau proteins. Firstly, it binds to and helps eliminate disease-causing mutant tau proteins. Secondly, it acts as a chaperone, ensuring that tau proteins fold correctly. Lastly, TRIM11 can dissolve existing clumps of tau proteins, promoting their proper functioning in the brain. On treating mice with TRIM11 gene, researchers observed that there was a notable reduction in the development and accumulation of the tangles, and they had improved cognitive and motor abilities. This suggests that TRIM11 could be a promising target for future therapeutic approaches in treating neurodegenerative diseases associated with tau protein abnormalities. A recently discovered smartphone vulnerability may enable hackers to trace a user's location. A research team uncovered this flaw by using an advanced machine learning program to analyze data from basic SMS system that has been in use since the early 1990s. The system works like this. When someone sends you a text message, your phone automatically sends a notification back to the sender, confirming the message's delivery. It's like a receipt for the sent message. Using this method, a hacker can determine your location, even if the communications are encrypted. Each time your phone sends an automated delivery notification, it leaves a fingerprint of your location. This vulnerability went unnoticed until Bitsikas and his team utilized machine learning to create an algorithm that can identify these fingerprints. As of now, there's no evidence that this vulnerability, which primarily affects Android operating system, has been exploited. However, the potential for misuse remains a concern. The biggest concern is that this flaw can be exploited to locate government leaders, activists, or others who wish to maintain their privacy. Bitsikas shared the research with GSMA, which is a global organization that oversees the health and welfare of the mobile ecosystem. GSMA informed him that they intend to implement countermeasures to make the hack more challenging to accomplish, but they acknowledged that it won't completely eliminate the possibility. And these were the top science news of the last week. Thanks for joining us. Stay curious, stay updated.